So the last thing we're going to talk about in this second section on limits are some properties of limits. And these are like different rules we can use to help us combine limit values, like if we want to add functions or subtract functions together. So taking a look at the information at the top, as the x's approach a of the f function, we get closer to a height of L. And as we approach the same x value of a for the g function, we are approaching a height of m. So we're going to keep those in mind as we go through some of these different limits. Now, I really don't want you to overthink these. Okay, I'm hoping that they're going to be easier than at first glance. And most of them, most likely, are going to be kind of common sense to us. So if we're going to try to evaluate the limit of the f and g function being added together, we can simply take a look at their individual limits, okay, L and M, and add those together. So if the limit value for f was L and the limit value for g was m, we can add those together, and that would be the same limit as if we were to add the functions together. Very similarly, we can look at the individual limits, L and m, and in this case, we would subtract their values. In the next example, we can take a look at the individual limits, L and m, and divide those. We do have a stipulation here. Okay, this particular limit exists provided that the limit from the g function, okay, that m value is not 0, okay, because we cannot divide by 0. For the next one, we can take the individual limits, L and m, and multiply them together. So I think those are pretty common sense. The next three are a little different, but still easy in my opinion. If we were to take the f of x function and multiply it by a constant, we can take the f of x limit that we know, okay, from the top that would be L, and we can simply multiply that by the constant of c. Similarly for the next one, if we're going to raise f of x to a power, we can take the individual limit from f of x, which was L, and raise that to a power. The last one's a little different because we're not talking about f of x or g of x anymore. We're simply going to take the limit of a constant function. So if you think about a constant function that is a horizontal line, and we want to approach the x value of a from the left and the right. And notice as we do that, those arrows would be approaching each other, and they would meet up at the height of the constant function, because constant means the height never ever changes. So it looks like our limit value would be c, okay, just the constant itself. So we're going to use these limit properties on the back to actually go through some more concrete examples. So on the back we have two graphs, f of x and g of x, and we're going to use those graphs to help us evaluate these different limits, okay, applying those properties. And remember, if a limit doesn't exist, we'll be sure to state why. So looking at the first one, we want to approach 2 from the left. Let's first take a look at the f of x graph. Here's the x value of 2. Coming in from the left, we're approaching a height of 3. On the g graph, here's the x value of 2. Coming from the left, we approach a height of 1. And we will add those individual limits together to get our real limit answer of 4. Looking at the next one, we're going to approach -1, and notice how this is an overall limit, so we have to make sure we come in from both sides. Looking at the f of x function, from the left and the right, we approach a height of -6. And for g of x, coming from the left and the right, we approach a height of -1. According to the actual function that we want to evaluate the limit for, we got to multiply the f of x value by 2 and the g of x value by 3, and we'll subtract those. So -12 plus 3 will give us -9. Alright, moving on, let's go ahead and approach -3 from both sides. So for f of x, from the left and the right, we approach a height of -2. And for g of x, we're going to approach -3 from the left and the right. Clearly, that's the location of a vertical asymptote, and a limit, an overall limit, we'll say, does not exist at a vertical asymptote. So negative 2 minus does not exist. That's not really able to be calculated, so must mean the overall or actual limit value doesn't exist as well. Let's go ahead and check out the next one. Let's go ahead and approach 6 from both sides. So for f of x, coming from the left and the right, we approach a height of negative 4. And for g of x, we approach from the left and the right, we get a height of positive 4. And according to the function that we actually want to evaluate the limit for, we need a negative 2 constant multiplier up top. So it looks like we get 8 over 4, which would simplify to... Oh wait, I did that one wrong. I was at 4. We got to go to 6. Coming in from the left and the right on the g-graph, we approach a height of 6, not 4. So 8 divided by 6 would change to 4 over 3. That looks a little better. Alright, let's go ahead and approach 4 from both sides. So on the f graph, from the left and the right, we get closer to negative 3. From the g graph, oh, there we go. From the left and the right, we're approaching a height of 4. Okay, that's what I did previously over here by accident. And we want to multiply all that by 2. So negative 6 times 4, we'll get negative 24. Let's try the next one. Now this one only involves f of x, so we'll approach negative 2 from both sides. From the left and the right, looks like we approach a height of negative 5, and we will square that according to our limit function. Negative 5 squared, 25. Okay. Alright, let's go ahead and check out the bottom ones. I'm going to zoom out a little bit just so we can see the problem and the graph. Okay, so this should be a little close-up for you in front of you. I know I zoomed out a little bit to fit it in. So this one only involves the g of x function, and we want to approach 2 from the right. So here's 2, and as we come in from the right, we have a height of 6. So we want to take that limit value times 2 and square root it. So it looks like we'll simply just have the square root of 12. You do not have to simplify that if you don't want to. You can leave it as the square root of 12. Alright, so both functions coming in from 2 from the right. F of x, we approach a height of negative 2. G of x, from the previous example, we said we approached a height of 6. So it looks like our limit for this function would be negative 1/3. Last but not least, we're going to approach negative 1 from both sides. So on the f of x, left and right, we approach a value of negative 6. G of x, from the left and the right, we approach a value of negative 1, and we want to subtract those values together. So negative 6 plus 1 changes to our limit value of negative 5.